to Stephanie.
Let him get away from the camera. Hi, Stephanie.
Fathers of Zoom. Now, really. She runs River, and I just brought them to a casting.
Perfect.
Yeah, it's amazing.
And we actually might have Billy back in the fall.
Yeah.
He gave an order this year. You should come.
I know, like I was fighting all day.
Yeah, I'm working with Melody. Well, it's only first conversation.
Whole picture from absolutely to yes. Now it's all legal contract.
That's basically important. Okay, let me finish this up and well, it looks like you will not be visible.
The contrast.
Yeah. I have no clue what to do about it. Okay.
That's it.
Let me check if the stream is streaming. Or you can walk through this, the wave and all, but after that.
So it captures just the ambient audio. So just the ambient.
Good. I can see myself. Cool.
Okay, folks. Okay. We'll have networking session afterwards, and you will have a chance to talk to another person on the other side. But now we'll start. So please take a seat, and we'll start the presentation. Okay, and hello to everybody on the live stream. Hopefully this works out. it's the first time. We'll see how it all goes. So now I want to introduce Rick Viscomi, who took 4 years to come back and give a presentation. And he has an amazing job now. He helps understanding performance of the world for all of us at HTTP Archive. And that's what he's going to talk about tonight. Please welcome Rick.
Can you all hear me? Is the mic loud enough?
Yeah.
Okay, great. All right. Thanks for the intro. I can skip a couple slides now that you've talked about who I am, what I do. So my name is Rick Viscomi, and I am, let's see, waiting for the slide. There we go. I'm a maintainer at HTTP Archive. It's an open source web performance and accessibility and security tool. My day job is a developer programs engineer at Google. They let me work on HTTP Archive full time. My focus is on web transparency, not just performance, which is pretty good. I joined the DPE team about 5 months ago. Before that, I was a web developer at YouTube. So it's kind of nice to have both sides of focusing on the performance of a particular website and now transitioning to looking at the web performance and everything else of the web as a whole. That's what I wrote. I'll introduce the rest of the team. Steve Souders created the tool in 2010. He was inspired by the Internet Archive, which you all might know does the Wayback Machine. And while that focuses on the content of the web, Steve was inspired to make something that tracked the composition of the web. He wanted to know how it was built and track that over time. So he was really the mastermind behind the whole thing. He wrote a lot of the initial code of the pipeline and the website itself. He also had help from Pat Meenan, who you might know as the creator of WebPageTest. Pat helped set up a bunch of private instances of WebPageTest to run these thousands of tests. And Ilya is kind of like the head cheerleader of HTTP Archive. Since Steve left a few months ago, Ilya has really taken on the role of driving the vision, and he also is responsible for integrating BigQuery into the pipeline, so you can do a lot of really deep analysis of the data. So that's who we are. This is what HTTP Archive is. It tracks how the web is built, and I highlight these two words because they're really the pillars of HTTP Archive. We track how the web is built. We deconstruct the web into its raw materials. You can think of it like when a house is built, it's made up of a bunch of lumber, nails, and hand tools, and power tools. If we wanted to understand how a house is built and learn everything we can about it, we want to know how many nails were used. Where did you get that wood? How much did it cost? 2x4, 4x4, everything about the web. And when we say we want to track the web, we want to learn how it used to be built, compare it against how it's currently built. This enables some interesting analysis. We could correlate things that have happened, certain events in time. For example, when they started enforcing smoke detectors in houses, you might be able to say, did houses get safer after this point? Did fewer houses burn down? For the web, we can look at web standards and see how did that actually help. Did a new API improve performance or security on the web? Another important thing about tracking the web is trends. You can see the trajectory of where things have been, where they are now, but also where they're going. The right side of this page is the web HTTP Archive looks like today. It's a trends page. It's a time series of data. It's a bunch of metrics, including page transfer size, how many bytes were shipped over the network, and many, many other stats. On the left side, these are more of snapshots in time, what the websites looked like at the time. The great thing about the trends page is that you can go back 7 years and look at how the web is built. This wall of text is a high-level description of what the HTTP archive does. It tracks 500,000 websites as defined as the top websites by Alexa. We crawl the home pages only on both desktop and mobile web. It runs on web page test under the hood. We get all of the metrics that you've come to love from web page test, the waterfall, hard traces. We've recently integrated Lighthouse audits. If you're not familiar, Lighthouse is a tool that measures progressive web happiness. Not just performance, but also security and accessibility, how modern the site is. And also custom metrics, which we'll get into a little bit later, but the gist of it is you can run JavaScript on the page at runtime and gather metrics about how the web is built, how the web page is built. Gives you access to things like the DOM at the time, the JavaScript global scope. HTTParchive.org is our front end. I like to call it the tip of the data bird. It has the trends and stats, but also a discussion forum where if you would like to get help with some of your analysis, there's plenty of people there happy to provide assistance. If you found something interesting, you can share it there. The BigQuery and cloud storage repositories are where the raw data lives. And it's immensely helpful to have this raw data so that you can provide your own slicing and dicing if you want to do something different from what we would do on the website. So to take it, sum all that up graphically, every other week, HTTP Archive runs 500,000 websites. Technically 1 million if you count both desktop and mobile, on 134 different web page test areas that sit on the Internet Archive architecture. And HTTP Archive, the server, manages the syncing between the Google Cloud services, BigQuery and Google Cloud Storage. When I say Databird, this is what I mean. We have these curated stats and trends that we handpick, but there's so much more beneath the surface that's ready for mining. There's things that we don't even know exist yet. So we really implore everyone, dig into the data and let us know what you find. So that's what it is. Show of hands, has anybody here used HTTP Archive before? Maybe about half, that's really good. So we found that 3 main groups of people use the data. Scholars have used it as a source in their research papers. This is pretty cool. It's included in publications like ACM, IEEE. The community uses HTTP Archive to answer questions about the state of the web. Eric Lawrence wanted to find out more about Brotli compression algorithm and its proliferation on the web. Tammy Everts, when she was with SOSTA 2 years ago, noted that the average web page was exceeding 2 megabytes, and we'll see that record has been broken recently. This was big news at the time when this happened last year, or actually, no, yes, last April. The average web page size exceeded about 2.4 megabytes, which was the size of the game Doom. And I think the reason why this resonated in the community is because you think about how much that game did and the experience you had and the size limitations at the time. And when you think about it in terms of give a website that same size restriction, and it just wastes it, right? It has bloated images, uncompressed everything, scripts and styles. So this is really what I love about HTTP Archive is that it gives you these insights about where the web is going. This trend line on the right just shows how you can predict the future and see where the web will be, and hopefully make changes to avoid inauspicious milestones like this. Also, the industry uses HTTP Archive data for calibration of the schools. Lighthouse tool, like I mentioned, in part of its page weight audit, looks at the typical size of a web page. Now it's about 3 megabytes, and sets that as the threshold. If your website exceeds this amount, then it has failed the audit. And also, Addie and Sean from Webpack have a default performance budget of using HTTP archive data on average amount of JavaScript served, and they'll let you know if you've exceeded that budget. So this is really cool stuff. Let's dig into some case studies. The average web page, or the typical web page, comes up a lot. People want to know how big it is and how it got so big. Tammy said it was 2 megabytes a couple of years ago. And we just got a tweet last week that the web has crossed the 3 megabyte milestone. The answer to your question, how big is the typical website, why is it, could be summed up in this one tweet. It's 3 megs, mostly Kubernetes. It's more than half responsible for Kubernetes. It's about 1.7 megs. And where did this data come from? From the stats page that I just showed you. So the data above the surface of that data bird is really easy to access. If you have high-level questions like this, you can visit the website. But you may wonder, where does that data come from? How do you generate these graphs? It comes from the database. This is publicly accessible. It's BigQuery. There will be a few different queries, so I'll just take a second to explain what you're looking at. This is Google SQL. It's the legacy flavor. There are different couple of flavors. You're just selecting from the July 1st desktop crawl the average size in megabytes of web page. That's about 3 megs. Just one. I see some of you squirming in your seat when I mention averages. You know the answer to our averages. Okay to use. We should really be using medians instead. So this is the same type of query, just reworked for medians. We're selecting the 501st quantile out of 1,001 quantiles. The reason why it's an odd number is so that it's easier to pick the median. So if you imagine like an odd number of things, like I'm holding up 10 fingers, if you try to find the middle one, you're stuck with 2. So you have to either choose one, the other, or a combination of the both, which is imprecise. So if you start with 9 instead, and you work your way towards the middle, you're left with only 1, and it's easy to say, this is the median value. And now looking at the value itself, it's only 1.4 megs. We still haven't crossed the median web page being size of it. So consider the context when you're given numbers. Is it the average? Is it median? Some other percentile? It's also important to mention, look at the other percentiles. You don't need to only look at the middlemost. 75th, 25th are really interesting. We're going to be changing the way the website works. You may be asking yourself, like, well, if averages don't tell you the whole picture, why do you put them on the website? So we will be changing the site to use medians and also some other percentiles to give a more complete picture of the distribution. Next case study digs a little bit deeper into the mine of data that we can provide. We had recently exposed JavaScript libraries that are detected on page. And this is really, really cool because it can make use of the custom metrics that I had mentioned earlier to inspect the JavaScript global scope and see which libraries are currently on the page. And it can even tell you what version of that library is being used. So you may ask, what are the top libraries? And as a follow-up, how fast are they, right? We care about web performance. What can we learn about libraries on the web? So here's a relatively simple query to find out the top 10 JavaScript libraries. You may notice that the table name here is scratch space. That indicates that this is a temporary table generated just for the purpose of gathering all the JavaScript library information. Check out the discussion forum, which I'll plug later. I go into how I generated that table. It's really interesting how you can massage the data to get it to do what you need. But for the sake of just getting the top 10, this is relatively simple. Are there any guesses what the top JavaScript library is? jQuery, and we say 1 What percent of the web do you think is jQuery? 30, 90, too much. WordPress. That's a good one. 100. So it turns out 83% of the web uses jQuery, and jQuery is by far the #1 library. The #2 library, which is also a jQuery library, is about a quarter of the size. This is huge. We shouldn't forget about jQuery. As a web researcher or analyst, I want to dig into this data a lot more. I want to find out why is it the most popular? What kinds of sites is it on? And it turns out WordPress plays a huge role, and also the 1.x versions are still in heavy use, so the most popular versions. So there's a lot that you can do just with library information, but let's find out more about performance. So, actually, I have to show you this graph first. So, when you take all of the libraries, not just looking at the top 10 top them, you can't even see the tail of it because jQuery is so huge. So what I had to do was make a logarithmic y-axis just to see the rest. And some other interesting data points here to call out are AngularJS has 2% share of the web, about 9,000 out of the 500 that we checked. React has 0.4%. That's 2,000 websites. But of the 0.4%, if you only look at the top 100 websites, React is in 3%. There's a heavy skew towards the most popular websites using React. Some of the interesting insights you can get when you join data against some other performance or ranking information. And of course, I have to say, when you are doing these tests twice a month, it's very cool to see how this data changes week by week and month by month. You can see which libraries are becoming more or less popular. I did an analysis a few weeks ago and found jQuery, Modernizer, YUI. These libraries are actually getting less popular. The ones that seem to have been replaced with some standard native APIs are becoming less necessary, which is a good sign. So onto the performance data. So this query, you don't have to read all of it. It's just showing that you can join a couple of tables together and get things like the start render time, the amount of JavaScript that was being served to the page. Let's just see, is there any correlation between JavaScript library popularity and performance? Here's the raw data. Interestingly, jQuery websites tend to have a faster start render time, and not the fewest, but one of the fewest amounts of JavaScript served. I don't know. Let's try to aggregate all 100 libraries and see what we can find in the correlation methods. When you run queries on BigQuery, you can export the data into a Google Sheet, and they give you a nice way to get the correlation coefficient. So we will do that. And this is what we get. The correlation coefficient goes from -1, which is a strong negative correlation, +1, strong positive correlation. And anything close to 0 means it's a weak correlation. So this is weak sauce. There's not a lot here. This is not a strong correlation between performance and JavaScript library popularity. It's not that we failed to find interesting data here. It's just that we explored an avenue and it turned out to be dead. When you're doing analysis with big data, sometimes you have to try a few things to see what works. I'm sorry I didn't have anything more interesting to say with this data, but that happens. The third case study was also really interesting because it makes use of this new Lighthouse data. One of their audits is the lang or language attribute, and it checks to see if the website has any invalid uses of it. And if it has at least one, it fails the audit. So we can ask, what % of the web has invalid attributes? Why are they invalid, and what can we do to fix it? So the query here uses the JSON extract method to dig deep into the JSON Lighthouse report to dig out the score. And it's a binary metric, it's just true or false, and we're grouping the counts of each. So this is really cool that we're able to get aggregate information about Lighthouse. Before we integrated, we were only able to get information about a single website at a time. But now 500,000 websites can be analyzed for progressive web happiness all at once. And they have about 80 audits in there that we get for free now. Does anybody have a guess what percent of the web has valid language attributes? 10%? 60? Prepare to be surprised again. 99%. Asterisk. If the website did not have any lang attribute, it is automatically passing the test. I think the real data is about 3% of the web uses a lang attribute. The astute audience member may notice, wait a second, you said 500,000 URLs. How come true plus false is about 425,000? So not all of the tests complete successfully. Some of the URLs that we run through HTTP Archive have died a long time ago. Some of them are still stale. We also have a limit to how much data we can put into BigQuery. It's 2 megabytes of data. Websites that have really bad Lighthouse scores tend to have a lot of things stuffed into their report, like a lot of things wrong. Sadly, those are the ones that I want to dig into. Like, they have a lot of things wrong. I want to learn about what I can find from them. So anyway, that is the scope of the problem. Now let's try to find out more about individual cases of what went wrong on these 424 websites. We can use Lighthouse's details property to actually extract the invalid values from here. And when we wrap this query in something similar that just aggregates a count of how many invalid values we have, we get something that looks like this. So because websites can have multiple lang attributes, it turns out that there are maybe on average 2 language attributes per page. And the results here are actually, they fit into only a few buckets. So let's dig deeper into what those buckets are. Let's just get these out of the way. Some nonsense values. It doesn't seem like the code author meant to give a language value. They just put some junk in there. Maybe the template spit out some garbage. Maybe they intended to say, I don't want to specify any particular language, but there is no valid way to say no particular language. So if you wanted to do that, you would just omit the attribute altogether. Digging into the more interesting values here, it seems like people are confused about whether to use the TLD, the top-level domain of the website, like the .com or .cz for Czechoslovakia, as the language tag. There is a resource called the Language Subtag Registry, where they provide all the mappings of language and region to the correct subtag. So Czechoslovakian subdomain CZ, the Czech language actually is CS. Georgia, KA, Kazakhstan, KK, China, ZH, Japan, K. And another common problem, which is the number 1 and 3 problem, is people getting confused between locales and language values. They have the right language subtag. ZH is Chinese. CN is the China region, so it's Chinese as spoken in China, and Chinese as spoken in Taiwan. And the problem here is the delimiting. They're using underscores, when really the language attribute needs to be delimited by hyphens. It also has to be uppercase region, but if you noticed in the query, I had to lowercase in order to match. So I won't hold it against anybody here. And the W3C article on language tags also suggests drop the region if it's not necessary. Japanese, as spoken in Japan, could be redundant, so just say it's Japanese, just use Japan. Sure.
Why wouldn't standard adjust so it's not case sensitive and more than that would?
The question is, why is the standard so specific? It is what it is. Sometimes the web is inconsistent in APIs. I have no idea. I wish things were more consistent and more tolerant of similar, like we know what you mean when you say ZHCM. It's pretty clear, but you're right. It would be nice if it did support both. Okay, so those are the case studies. Just to sort of start wrapping up, a couple of things that are new in the tool. Lighthouse integration, you have 80 progressive web app or PWA audits available. Third-party JavaScript libraries are fully queryable now. Pat has done great work to upgrade the test agents over to Linux. It turns out that that's a little bit faster, which was needed to run the Lighthouse audits because they take up a bit more time. Fun fact, the crawls are spaced out every 2 weeks because it takes about 2 weeks to run a million websites. So once we start adding more to the tool, we have to sort of cut back somewhere else. Yeah, but
does time of day or time of week affect any of the metrics? Like, I imagine like time to get the first byte might be affected by whether it's 3 p.m. on Friday or...
The question is, does time of day or week have an effect? And it absolutely does. If we happen to be crawling on Black Friday or Cyber Monday in our case, yeah, the web will be a little bit slower that day. That might get the effect. We do run each test 3 times and choose the median. Hopefully that'll smooth general inconsistencies out. But I think on the whole, testing every other week sort of helps to alleviate some of those things. Okay. So that's what's new. Coming soon, things that I'm really excited about. We want to know, for example, is this website using WordPress? We had mentioned jQuery and how it's very prevalent on the web. Why is that? It would be great if we could just say, of the jQuery websites, how many of them are built on WordPress? Is there anything we can learn about the web slicing by these different demographics? The more demographics we have, the more we can fine-grain understandings we can have. Having the JavaScript library information allows us to join that again with security information. Tim Cadlick has been doing some work with the Lighthouse team to integrate with the SNCC vulnerability database, which kind of gets into scary territory. Now we have a database of 500,000 websites, and we can easily query what are the vulnerable ones. So if you're a hacker, you can just hit the database. So it's almost unethical to run it, but I come from a web transparency background, and I really feel like you need to shine the light on the dark parts of the web in order to make it better. So I think the more information we have about the state of the web, the better we can make it. We're moving away from just a wall of metrics that you scroll infinitely and discover on the website into more curated reports, bundles of relevant related metrics. For example, we'll have a JavaScript report or an SEO report, PWA report. You'll be able to find exactly what you're looking for and all of the related metrics that have to do with it. We're going to be moving away from unresponsive or uninteractive pie charts and finally getting some more interactivity. We're going to be using the HiCharts library to help make things pretty. We're working with a designer right now that the same kind of theme that you see in these slides will be what the website will look like. So we're excited about it. Maybe we'll even make the website a PWA itself. Part of my responsibility as both a maintainer of the HTTP archive and on the Google side of the house as a developer relations engineer, I will be working on a video series. So I'll be sitting down with some prominent members of the web community and asking them questions about some things that we see in the results. I might sit down with Tim and say, hey, what's up with half the web being vulnerable? Like, what can we do about that? I might sit down with Addie and talk about that. So I expect a lot of really cool things to come. Some things that we really want to happen, but we're farther away from. We'd love to move away from Alexa, primarily because they stopped updating their list of top 1 million sites sometime last year. So we're sort of stuck with a scaled version. We would also really like to get information about the category of website. Is it a news site, e-commerce, travel? It would be great to break down in addition to like WordPress or not. Learn about what is the systemic problem with travel websites. Could they do something that we need to address at that level? We'd like to move beyond just the 500K, thinking about millions of websites. We want to tell the still lots to learn from them. Speaking of millions of tests, I have to mention our sponsors because they make it possible. It sits on Internet Archive architecture. We're part of their data center. But all the logos that you see in this box here have contributed in some way to either allow us to use free quota on BigQuery or gives us money for servers. So if you're sitting here and you're thinking, well, maybe my company might like to sponsor, hit us up at that email address. I can give you more information. Or if on a personal level you feel like you'd like to contribute, we'd love to have more help. You saw my wish list of things. I'd love to have you help out. Here's our GitHub account. We have a few different repositories, both front and back end. This is the discussion forum that I had mentioned, discuss.httparchive.org. If you're digging into BigQuery and you're running into a wall, you don't know how to get around some error, we actually have one of the BigQuery developer relations engineers frequenting the forum. I ask him questions all the time. His name's Felipe Hoffa. He's been great. So there's a lot of help if you need it. Or if you just find something really interesting and like it's an awesome report, we'll bubble that up to the surface of that Databricks so that everybody can see it on the website. If you're interested in the day-to-day stuff, we have a Slack account. Unfortunately, it's the free Slack account, so guests can't join themselves. This is a bit.ly link that'll take you to a Google form. Submit your email address. I'll send you an invitation. It's a little secure, but we'll get you in. And this is my information. A lot of the findings that I come across in my analysis, or if anybody else finds something interesting, I tweeted at my personal account, retweeted at the HTTP archive account. And if you need to contact us on more private channels, here's our email address. And we have a few giveaways to give out. But before that, I'll take some questions. Go ahead.
So, question: looking at the trending stats on main page, sometimes I see a dip that goes almost down to 0.
Oh, right.
Can you explain that?
Yes, that needs explanation. So the question is, why is it when you're looking at the trends, things drop to 0 and then they go back to normal? Funny story, around December, our MySQL database ran out of 32-bit integers, and it failed to issue new IDs. So the crawl did not complete successfully, and we didn't get the data. Sometimes, what else happened? We have this 2-week window to complete the crawl, and if the crawl completes after a certain time, the cron jobs have not updated, or they haven't gotten the full data yet, so it has to be manually entered. So if it's a recent crawl, like the July 15th crawl should be ending in a couple of days, but it'll probably be another week or two before the data comes in. So it could be a problem of the data's gone, it's never coming back, or it has to be manually kicked in order to come back. And if you see something like that, the GitHub issue list for the HTTP archive account / HTTP archive repo has a lot of the issues like that where we're investigating. So if you see something reporting, you can also let me know if there's an issue.
Yeah, on the library analysis that showed, did you find any interesting things about you think of the combination of those libraries, or like the number of, not just the number of string tags, but the number of libraries that showed up?
The question is, did we find anything interesting about combinations of libraries? I would imagine, do jQuery websites typically get bundled with jQuery UI?
Yeah, but you have stuff like, Swift Object and Google Maps, which probably aren't running the whole site, but running some content on a site.
Yeah, the short answer is I have not done that analysis yet. I'd be happy to work with you if you wanted to build a query to find out that information, and definitely post it to the discussion forum so everyone can find that out.
I'd suggest particularly interesting sites that run multiple versions of jQuery at the same time.
That is a very good problem to ask. So we're limited in, because of the detection methodology, the way it works is we look for, like, for example, like the dollar sign. If that exists, it could be jQuery. And we also look for some telltale properties on that dollar sign object, like FN. There can only be one object assigned to that variable, dollar sign. So I don't know if we could extract multiple versions. One thing we could do is, and this has been around forever, this feature, you can look at the requests that were made during that page load. You can see, usually in the request URL, it says jQuery 1.4.1, and you can see the version in there. So you could kind of do the analysis that kind of hack it. Yeah.
Does Webpack foil that role detection mechanism?
Does Webpack foil it? It definitely could if it wraps everything in yeah, that's definitely a limitation.
I don't think React is available as a mobile on our websites. So I would imagine that less than 1% is not to be like a React partisan or anything, but I imagine that's an underestimate because it's associated with Webpack.
So yeah, there's. I'll repeat the question. Can we be missing out on some libraries by only looking at mobile scope because not all JavaScript objects are mobile accessible? That would definitely mean that we're undercounting. But it's good to know that, like, the false positives are very low, and the negatives are also.
So when executing the web or maybe you can establish that do you guys run this manually? Is there some like, oh, we're going to say about 2, let's wait a little time before we execute these tests, so that we're not stuck with the malware and that.
The question is, what do you do when the website returns a 500 something response? So 500s are like the server head. For those, we don't do anything. We have issue that we're tracking. We need to do better about error handling, not just failed tests, but if there are 404s, we need to sort of clean them up, leave them out of the test set. For 500s, I'm not sure if we would handle that as like maybe retry that again later. Sometimes they're valid 500 errors. It could be intermittent. If in the 3 runs that we try the website, if all 3 of them are 500, I think we might just give up after that. But it is a really interesting idea. Like if it's a temporary issue, come back again. Yeah, I'd like to see more intelligent error handling.
For performance metrics that we capture, I assume web-page test metrics are captured. What about the rest of the standard APIs? WebPC, padding, user padding, things like that. Are they all captured as well?
The question is, do we get more than just the web page test metrics? Do we get the underlying map timing APIs? And the answer is yes. Web page test extracts the data from the DevTools protocol, and it includes like resource timing information. All that's available in the raw par file that's collected during the test. And in addition to like the high level metrics, like this page had this amount of kilobytes of JavaScript and all that, you can dig into the aggregate or the hard file, pretty much, the hard report. And you can get all that in the packet. There's really interesting stuff in there also. The DevTools protocol also includes feature counts. I think of a good example of a feature count. One kind of mundane one is like, is a form present on this page? But funny enough, somebody asked me recently, like, I need to know how many forms are used on the web. And I was like, I have a feature count for that. So anything that Chrome DevTools emits, we can get and say a feature count.
So with the passport working on YouTube, what are kind of some of these use cases for HTTP archive? And do you use it on like YouTube pages, on embeds, on other sites?
So the question has to do with my past life at YouTube. So YouTube is a funny example because it's not a traditional web page. I hate saying HTTPS. It only runs on home pages, and the YouTube. When you think of YouTube, you don't think of it as home page. You think of page with the video. That's really what I would like to be tracking. But in that particular case, it doesn't apply. Not to mention the fact that I may be thinking too deep with that question, but YouTube as a web app doesn't follow the traditional model of where on-page load and document complete now. It really has to do with when did the video start playing? What were the blockers to video playing? It doesn't matter when the first, I guess first paint may matter. Interactivity matters. If the person wants to pause the autoplay video, that matters. And it's sort of hard to just as a blanket statement say, these are the performance metrics we care about. On-load time or time to first interactive paint, they go on and on, PWA metrics. But for YouTube's case, like each individual website has its own experience and what the user is there to do. A news website is pretty much all about the content, and maybe about the headline and the image. New York Times I looked at a while ago, and they changed fonts in the masthead a lot before they actually finally start to paint the actual article. So I would say some of the things I learned about the web and specifically performance from YouTube is not all websites are created equal. It's difficult to make generalizations about the web with a tool like this, but you sort of take the position that you're looking at so much, things sort of even out if you're looking at them.
So following up on that question, you guys planning to add the content pages to the drawing?
Are we planning on
Google? You think that what are the top pages in certain sites for those pages? Because React, for example, is a good example of not using the Webpack, maybe Kida, also probably not on both sides on the front door, on the front page, but it would be shown up on some of the other pages.
the question is, are we planning to crawl secondary pages? And that would be awesome. I would love for that to happen. Again, we're just limited by capacity right now. We can hardly get by with just home pages. Lighthouse does something really cool where they like reload the page a few times and are able to detect service workers because they're not immediately available on first load. So it kind of does the realistic experience like that, but we don't do secondary pages. You have to find a way to determine what the secondary pages are. You could, find the masthead nav bar and click the first link, for example. It's not a difficult technical challenge to implement, but just having the capacity is really what we're going to be talking about.
Two questions. One is, I remember in the original HTTP archive was available to install on your own and run as your own database. Is it still possible? And what is required of it?
So the question is, could you roll your own HTTP archive?
For your subset.
For your subset. It is possible. I don't know of anybody who does it. The code is open source. If you want to generate your own front end and supply your own data, It is possible. I think now would be a bad time if you wanted to start that kind of project. We're going to be rewriting a lot of the back end. Steve started it in 2010, and a lot of his code is still around. We're looking to upgrade it. And, in addition to the front end redesign, we'll be digging into the back end, going from PHP to Python. So if you wanted to fork it, wait for that to happen.
The second question, I assume you're not capturing screenshots.
The question is, are we capturing screenshots? And we are. We have the full film script, and I'm assuming you can generate the video from the film script. Something that's really cool is you can, the web page test ID is in the database, so you can extract that ID, plug it into a URL, http://webpagetest.org/result/the ID. You can get the full results as if you had run it on web page test. You can see the screenshots and everything. Additionally, the current website provides a UI for you to search for a particular URL, and it'll give you an HTTP archived version of the web page test results page. Unfortunately, we're going to be deprecating that view. It's not a very popular feature, but the IDs are still there if you want to dig up a particular URL. You can totally just check out the raw results on web page testing. So we have an SSL stuff.
You mentioned that each call has three iterations of the site. I'm assuming you disable caching when on subsequent calls.
Yeah, the question is, we check the site 3 times, do we disable caching? We do. So the 3 first views, we don't track the
And certainly, just a clarification of what you just said about the deprecating feature. If I wanted to, you said you were hoping to be able to sort of silo the websites in sort of industry.
Yep.
Is that something you're deprecating, or is it something you're looking to expand?
The question is, are we looking to deprecate or expand siloing websites by category? And that's something we're looking to expand. We don't really have the capability now. If such a database existed where it was a mapping of URL to category, you could join with that data. But I'm not aware of any freely available source of data like that. We're looking into getting that data into BigQuery and have that as a first argument.
But me as a user, I could identify, let's say, a handful of interested targets and go pick them out, correct?
Yes, if you knew exactly what websites you're looking for, you can totally have a where clause in your query that says where the URL is in this set of known whitelisted URLs.
And what field is that? Is that the
That would be the URL. But we have to chat more about SQL. Oh, good question. If a website has a separate mobile site, will we hit that? Or I'll just get to the answer. We don't. We only know the top 500, and we assume they're all desktop. And we hit them with emulated mobile user agent string and viewport size. So we let the website do the redirection. If they can detect that we are a mobile website or that we're a mobile browser, they'll send us the thing. So you will get a few extra redirects in the test. But we don't, for example, navigate directly to m dot whatever. We ask for www.
Have you seen more FBO stuff come into play, and do you think that affects results in a meaningful way? It will depend on all of the spin and does that factor in the results, and you see more people fluctuate the results, like
Have we noticed people gaming the system trying to optimize optimize? Is that your question? Like sort of trying to.
Well, give me one administrative impact aside from
Has it been a side effect? That is a good question. I'm not sure I'm prepared to answer that specifically. I will say that the data is there. It could answer that question. I just haven't found it out. They're kind of shooting themselves in the foot if they did. For example, like if you were to run an email page through web page test, it'll have a really fast first paint time. But the problem is it's going to be the progress bar showing you that it's getting Gmail. I don't think Gmail's gaming the system, it just is a side effect of the way they load the page. And that is another example about, the app that you're testing has its own primary metric. It would be great if we could standardize on it for the app to say, this is my primary metric, this is what I care about, and this is what you should track, is what I think matters. So, to answer your question, I don't know if people are doing that.
that's not really capturing on the editors and stuff.
We do have the question is, would that be captured in the backend time metrics? We do track server response headers, but we don't have much visibility beyond that. And I'm not sure if it would be in the backend. I think we could probably detect it client side, but it would do that. Is this a spinner? And it's a hard question.
So, considering that you're storing the entire HTML5 files, I would assume it's possible to write a computer that would release all the ad servers? How much additional assets they load at one point? Like, locally present?
Is it possible to parse out the ads?
Yeah, to find essentially the ideas of which are the slowest networks.
Can I extend that to all third parties kind of analysis?
Yeah. Can we find out the slowness of third parties? Yes. It might look similar to the performance versus library, JS library thing I showed. You might not get what you're looking for because there's so much data. It really depends. Like performance depends on a lot of things besides just like what JavaScript you load. You might be able to.
I'm more asking about like collapsing the whole series of the CDI thing. Is there a lot of assets loaded ready for etc. And I'm summing them up and saying, hey, this network for me, the user data from that, where's this one?
So it is possible to look at all of the requests externally and parse out just the origins, and usually you'll find like double click all those origins for ads are very, very popular. And if I'm not sure if you could, we absolutely could. I don't know how valuable it would be to look at performance breakdown by origin. It's one of those cases where you query first and ask questions later. I'd really be curious until I find out more. And sort of know how to navigate it. Sorry for that. It's okay. Sometimes you just have to dig in and then see what you find. Yeah.
That's a question. So, obviously, web page test and SQL data synthetic tools. Can you talk about using that and using that?
So, can I talk about the difference between a tool like HTTP archive and web page test, which are synthetic, and really is a metric for run tools? So, do you also want me to go into use cases and like when would you use one versus the other? Okay, so you might be tempted to think, oh, great, my website is in the top 500,000. How fast is it? You query HTTP archive, you get, I don't know, an onload metric, or whatever metric you care about, document complete, and you find that number. And you say, what, my website loads in 10 seconds, what is that? Crap. This is a synthetic tool. It's run under a certain set of circumstances. It is originating from the data center in California. It's on a really fast but artificially throttled network. It's supposed to emulate cable. A whole set of circumstances that may not necessarily accurately align with how users typically interact with your site. If you have a website that people interact with over mobile, make sure that you're looking at mobile experiences, 3G instead of cable. To answer questions about how fast is my site, you need a RUM tool. You need to have real user metrics sampled from the wild that you can aggregate and analyze. Synthetic tools can't really tell you this website is fast or slow, but what it can tell you is this website is faster or slower compared to the other websites that we tested. Relatively, it still makes sense. I think one of the most popular posts in the discussion forum is about speed and comparison of the top 100 websites. What is the aggregate performance metric there versus the rest of the web and the top 1,000? You could do analysis like that with a synthetic tool that runs over many websites. But if you were to look at particular cases, it wouldn't be
Considering that we took on that topic, do you have any plans of working source, which I think is one of the sponsors, right? And so sources for sure provides their own newsletter, at least for the user planning and the app planning, maybe exposing that for all the sites and then rebuilding separate platforms and being able to provide insight into the own sites.
So the question is, could we work with other companies to get more data? And my answer is yes. I would love to get more data and present the data in other ways. If somebody has a RUM dashboard, it would be great if we could say, like, your category of website has this typical performance, or from this perspective of the construction of the web, we could say, you're using a lot more JavaScript than your competitors.
Well,
beyond this performance.
I guess the question is more, do you treat the performance to do that? And as a side point, you can save a lot of money by extracting the data that you collected instead of running the service.
I see. So could we use the data that they collect from their customers and plug that in here? That would definitely be interesting. Then we'd kind of be combining RUM and synthetic data at the same time.
Also have separate databases.
Yeah, they should be kept separate and taken, considered. Yeah, it's a hard problem to have. I would love to have any data I can get my hands on. The more data you have, the more questions you can answer. But there are some logistics that need to be figured out. But we have not started this conversation.
I would say generally that we have a very hard time sharing that kind of data other than when we did it before. We can now before. They will have problems with their clients doing that. So
application could be just fine for this purpose. There is only 3 run if you have on the single site for 2 weeks.
that site might not enjoy sharing that kind of data. They collect for themselves, right? They collect it for their own business purpose, not for their competitors to know that they're doing. So that's basically usually the conversation that goes about it. We can probably ask them when they come on stage the part of the months of this and next years, following years, what they can share and what they cannot. But that's usually how this problem was voiced. Okay, a couple more questions, if any. No? One last one. No?
Has there been any discussion either in the archives or about extending the work that you are having because obviously seeing an increasing number of people like that would want data that's encyclopedia.
Are you asking about the devices themselves, like running tests on native devices? Or about more of a focus on the the URL, so actually start the test on the mobile website.
So I guess if running on the device in addition to what we have as a
So the question is, are we looking to running on actual real mobile devices? Short answer is no, we're not. I think the scalability of that is a huge issue. Being able to emulate it on Chrome helps a lot. We don't need any special hardware to run besides just a server and the Chrome browser. So the URL thing we could definitely do. We can do a better job of hitting the mobile website first and not worry about redirection. We can do a better job of emulating mobile more accurately. Right now we just pick like a, I think it's fast 3G connectivity profile. And we're also just hoping that they serve us the mobile website given their user experience. Yeah, we can do that.
Okay.
Thank you.
Okay. Thank you. Thank you, Rick. So before we go anywhere, let's do the raffles.